In this video, I will demonstrate the vector additions that was discussed in the first video. So, we all know that there are two types of vector addition. We have your graphical method and then your component method. Take note that when you are using your graphical method, you would use the tip to toe rule, wherein the tip of the force should be connected to the toe or the toe to the of another force. So, let us consider this problem. So we have your determine the magnitude of the resultant force acting on the screw eye in its direction measured clockwise from the x-axis. So first, we would demonstrate your graphical method of solving this problem. So graphical method. Okay. So first, let us identify the forces. You have your F1 is equal to 6 kilonewton. This is the magnitude of your F1. And then your F2 is equal to 2 kilonewton. This is the magnitudes. So the problem is the resultant force. You have your Fr is unknown, and then also the angle at clockwise direction from the x-axis. So when you say clockwise, so we would go to the clockwise direction. So pag ganito tayo, clockwise direction. Okay. So let us first use your graphical method. Okay. So if I have this 60 degrees, 45 degrees projection of my angle, okay, so let's say this is my figure. So we have your 6 kilonewton projection. I will exaggerate the values. 6 kilonewton projection, and then your 2 kilonewton projection, which is you have your 45 degrees, and then this is your 60 degrees. So by a parallelogram law, we will project each forces or vector quantities in parallel with each other, but take note that you should not alter the direction when you will project the value of your forces. So this projection will just show you that we would create a parallelogram figure. Okay, so changing our pen color. So let's say that I will project my 6 kilonewton force. So this is my projection of my 6 kilonewton force. 6 kilonewton. Now take note, do not alter the angle of your 6 kilonewton, which is it is 60 degrees below the horizontal or 60 degrees below the negative x-axis. And then we will project your 45 your 2 kilonewton. So take note that it is the arrow is going down, so you can see that it is on the tip of your 2 kilonewton is projected to the head of your 6 kilonewton. Okay, this is your 2 kilonewton. Never alter the angle of your 2 kilonewton, wherein the angle of your 2 kilonewton is 45 degrees below the x-axis. Okay, this is your 45 degrees. So the problem asks us to get the value of the resultant force and its direction below the x-axis or the clockwise direction from the x-axis. So let's say this will be my resultant force. This is our FR. Okay? So, from this point on, when you are talking about your graphical method, which means that you would or you will solve the problem using trigonometry or geometry. Okay? So you can see that this is 45 degrees. Okay? So without minding this one, this triangle, so let us mind this triangle, creating a perpendicular line to the hypotenuse of the triangle, you can say that this is 90 degrees and my theta 1 is equal to 45 degrees. Okay? Since this is 45 degrees, I may say that this theta 2 is equal to your theta 1, which is equal to 45 degrees. Right? So, knowing that that is 45 degrees, so I may say that my angle, let's say this angle, I will indicate is as angle alpha. My angle alpha is equal to 60 degrees plus my theta 2, which is basically equal to 60 plus 45 degrees, or it is equal to 105 degrees. Why is it that alpha is important? Take note that in order to get the value of your FR, we would use this alpha using your cosine law. So, solving for FR, so therefore we will have FR squared using cosine law, solving for FR using cosine law. Solving for FR. So remember your cosine law. So what is your cosine law? So your cosine law simply states that c squared is equal to a squared plus b squared minus 2ab cosine c, wherein your c is the angle opposite to the value of the magnitude c, right? So notice that our angle alpha is the angle opposite to our FR. Let's say that your C will be equal to FR, and then your capital C is equal to alpha, right? And then your A will be equal to your F1, and B is equal to your F2. So your A and B will be F1 and F2, so you have 6 and 2 kilonewton. So therefore, our F1 is 6 kilonewton and our F2 is equal to your 2 kilonewton. So this is your 6 kilonewton and this is your 2 kilonewton. Okay? So therefore, we have our C squared, which is your FR unknown, FR squared is equal to our A squared, which is your F1 squared, plus F2 squared minus our 2 F1 multiplied by F2 cosine our C, which is equal to your alpha. Okay? So, solving for this one, so we have our FR is equal to the square root of our F1, which is equal to 6 kilonewton squared plus 2 kilonewton squared minus 2 multiplied by 6 kilonewton multiplied by 2 kilonewton cosine alpha. Cosine alpha, which is equal to 105 degrees. Never forget to factor out your kilonewton, because kilonewton squared is just equal to kilonewton. Therefore, my FR is equal to, solving it using your calculator, we have our FR is equal to the square root of 6 squared plus 3 squared minus 2 multiplied by 6 multiplied by 2 multiplied by cosine 105. We'll have a value equal to 6.7979. So 6.79. Let's say I will round it up into my thousandths. 6.798 kilonewton. Okay, that is the value of our FR. So how will we get the value of the unknown theta, which is your x theta? Let's say that my unknown theta, or the value of your FR with respect to the x-axis, will be, let's say, beta. Natin beta siya. So this is my FR beta. Okay, FR beta. So which means that it is the angle from this triangle that was projected. Let's say beta is equal to, so how we solve for beta? So your beta is just equal to the angle of this triangle plus the angle of 45 degrees, right? So therefore I may say that my beta is equal to, I will project this angle as your phi, so phi plus 45 degrees. How will you solve for your phi? Okay, so solving for phi, let's say solving for phi, solving for phi, solving for phi, okay, go back to the figure. So how will we solve for phi? Take note that we already have our alpha, and then we have already have our FR. So how will you solve for phi? Using your sine law. Using sine law. Wherein we have our A divided by small a divided by sine capital A, which indicate your angle, is equal to B all over sine B, which is also equal to C divided by your sine C. Take note that your A, or your capital A, or capital B, or capital C are the angles opposite to your side A, side B, and side C. Okay? So, analyzing the figure, what is the angle or the magnitude opposite to your phi, or your angle phi, right? It is your 6 kilonewton. So therefore, I may say that my A is equal to 6 kilonewton, and then my angle A, which is equal to phi, which is equal to unknown, right? And then my B is equal to my alpha. Why? Because it is directly, it was already solved at our first step. So your alpha, which is equal to 105 degrees, and our FR, which is equal to your B, right? Small b, or the magnitude of B, which is equal to 6.798 kilonewton. 6.798 kilonewton. So solving for this one, you can see that substituting all terms, you have 6 kilonewton divided by sine unknown, or your sine phi, which is equal to 6.798 kilonewton divided by our sine 105 degrees. Okay, so cancelling out your kilonewton, because kilonewton divided by kilonewton is equal to 1. Therefore, I may say that we have 6 multiplied by sine 105 divided by 6.798, which is equal to sine phi. Solving for sine phi using your sine inverse, so we have phi is equal to arc sine or sine inverse -1 or sine raised to -1 in. So take note that this -1 here indicate inverse. Okay, so we will get the value of your theta or your phi or the angle divided by 6.798. So we'll have, solving using your calculator, shift sine 6 sine 105 divided by 6.798, you will get an angle equal to 58.488 degrees. This is the angle indicated by our phi. So solving for the direction measured clockwise from x-axis, so direction measured clockwise from x-axis, so therefore I may say that that direction is equal to your beta, which is equal to phi plus 45 degrees, which is equal to 58 58.4888 plus 45 degrees, it is equal to 103.5 degrees. 103.489 or approximately equal to 103.5 degrees. Okay, that is the direction of or the angle beta. So okay, this is the answer. So later on you may ask that why is it that it is not negative. So take note that we have projected it using your graphical method. Okay, so this is 103.5 degrees below the x-axis, so indicating that it is at that this is should be negative below x-axis. So therefore I may project my force as this one, 103 degrees. So this is 90 degrees. So this is your 90 degrees. So I will project this one 90. So this is our FR, 103 degrees below the x-axis. Okay, so this is your Cartesian plane, 90 degrees, 90 degrees. So this will be your FR. This is 103.4 degrees. Okay, so this is your FR, which is equal to 6.798 Newton. Okay, this is our FR. Okay, any question? If you will be question, just feel free to ask me or PM me in my messenger, or post it in our GC. Okay.